All right, here we go. We got Unit 7, Lesson 1, practice problem. So find the values of x, y, and z. So what you need to know for x is that the measure of an arc equals the measure of the arc's central angle. So you need to know that the measure of x from here to here, this is an arc, equals the measure of the central angle, which they're saying is 20. So for x, you're just going to say it equals 20 degrees. So they label arcs in degrees as well. For y, same deal. The measure of this arc will be the measure of this angle. You can kind of see it too, like smaller circle, bigger circle. Like, why wouldn't it be the measure of this angle? It's the same percentage of the circle. So this z, and this is going to answer z as well, because we know a straight line is 180, that means z is 160. So you can automatically say z equals 160 degrees, because 180 minus 20 equals 160. Because a straight line has a 180 degree angle. So 180 is half a circle, right? 360 is the full circle, so half a circle, straight line, 180. This is 20, that's 160. Okay, so z is 160, which means that arc y is also 160. And the reason being, the measure of an arc equals the measure of an arc's central angle. Pretty simple stuff. Okay, give an example from the image of each kind of segment. So a diameter is like two radii put together, basically. That's not, that's the worst definition. Hang on. Two endpoints on a circle going through the center. That's a little better. So two endpoints on a circle, and it goes through the center. So I'm already thinking GH. So GH is a diameter. All right. A chord that is not a diameter. So a chord is just two endpoints on a circle. And in case you ever are like, I don't know what is what, just go back to the lesson summary where it defines all these. Chord is a line segment whose endpoints are on the circle. All right. So a line segment whose endpoints are on the circle. And make sure you call this line segment GH. You could also say CB. That would have worked, or BC would have worked for the diameter. But a chord that's not a diameter, I'm just going to go DE. And then how about a radius? That's easy, from the center to a point on the outside. So how about AC? All right, identify whether each statement must be true, could possibly be true, or definitely can't be true. A diameter is a chord. Well, a chord is just two endpoints on a circle, and a diameter is two endpoints on a circle where it goes through the center. So all diameters will be chords, right? A diameter is a chord. Must be true. A radius is a chord. Two endpoints on the circle. That'll never happen, because a radius always needs to have one of the points like in the middle. So that'll never be true. So it can't. What about a chord is a diameter? Let's look at the definition. A chord has two endpoints on a circle. A diameter has two endpoints on a circle, and it goes through the center. So a chord could be true. not all chords are diameters, but some of them are. A central angle measures 90 degrees. Yeah, that could be possible. So like you could have like a central angle right here that measures 90. No problem. Central angle, just to give you an idea, is like, yeah, its vertex is at the center of the circle. So yeah, you could easily have a 90 degree. So it's not always going to be 90, so that could be true for sure. So that's number 3. All right, let's go to number 4. In case you're wondering, I'm going to end with the heavy hitters. So Ken Griffey Jr. rookie card, 89 upper deck. Tony Gwynn, 1983 tops. I got both of these in packs. It's pretty cool. Okay, write an equation of the altitude from vertex A. Okay, equation. Oh, that's unit 6, lesson 17. Which we didn't cover, but I want to try this. All right, so from vertex A, this is the altitude, right? It looks like it's a line. So we need the equation of a line. Now I know it goes through point 2, 1. It goes through that point for sure. Now what's the slope? Well, it's not easy because the rise is like 1, 2 1/4 and the run is 1/2. It's kind of weird. So I'm going to look here. I'm going to be like, oh, that's perpendicular, right? And remember, perpendicular lines have opposite reciprocal slopes. So I'm going to find the slope of BC. So the slope of BC equals rise over run, right? Haven't forgotten that, have you? Anyway, rise goes down 2, so -2. So from B to C, down 2. And then it goes over 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's a positive run and a negative rise. So the slopes can be -2/9. Meaning the slope of this line will be 9/2 because of opposite reciprocal slopes for any lines that are perpendicular. So now we're cooking. So now you just go y minus 1 equals 9/2 x minus 2. Because the 0.21 positive x positive y is on the line. So you just put it like this because it's y minus k equals m x minus h. All right, number 5. Triangle ABC has vertices at 5, 0, 1, 6, and 9, 3. All right. It almost works. 5, 0, 1, 6, and 9, 3. Is that Claire?
Yeah.
What's up, Claire?
Nothing.
I'm filming a video for school, but you can come sit in here if you want.
Okay.
You still want to go to the climbing gym?
Uh-huh.
All right, we'll go for sure. Just chill over there, and then feel free to ask me questions, okay? But stay out of the camera view. Got it?
Uh-huh.
All right. Okie doke, here we go. All right, so here's our triangle for number 5. What is the point of intersection of the triangle's medians? We didn't cover this at all, so I think I'm gonna skip it. Let's see though. The medians, what are the medians again? Hang on, Unit 6, Lesson 16. I don't know what those are, but let me just pull it up. Medians. Clay, don't play drums though, please. Alright, median. That's what I thought. Okay, cool. So vertex to the midpoint of the opposite side. Okay, so vertex to the midpoint of the opposite side. Alrighty. So let's see. Vertex to the medians. So we got a 3, 4. So this has to go over by 2.5. 3, 4. So I need to go 2.5. What am I blanking here? So this is 2.5. I think it's right here. I'm pretty sure. Would make sense. 3 right here. Should be where we're looking. Okay. You out of here?
Yeah.
Alrighty. Bye. I want to try to answer this one for you. Just so you know what medians and the intersection point of the medians are. So that's where they all meet. Okay, so that one's 5-3. Woo. Okay, number 6. Consider the parallelogram with vertices at 0, 0, 8, 0, 4, 6, 12, 6. Where do the diagonals of this parallelogram intersect? Ay, ay, ay. Okay. Let's create something here. Create ourselves a grid. Lot to juggle. I'm gonna be a parent too, so. Anyways, much rather go hang out with the kid, but I gotta do my job also. You'll find the right balance. Okay, so here's our coordinate plane. Now we gotta go pretty big on this, so I'm gonna go halves for this. If you're precise, you don't need graph paper. You can just build your axes yourself. No big deal. Don't give up on problems just because you don't have graph paper. And you don't even need graph paper for this if you get really good. But I always like to sketch what they're asking about. The reason I extended this a little bit is because I know there's a point 12.6. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 2, 3, 4, 5, 6. I think that's as big as it goes. Okay, so 0, 0, so that's right there. 8, 0, right there. Then we got 4, 6, right there, and 12, 6, right there. Okay, so here's our points of our parallelogram, right? And let's build it real quick. There's a concept that we missed because we didn't cover this, but I believe there is something about all right, I think it's 6, 3. Where do the diagonals of this parallelogram intersect? I'm gonna say beyond a reasonable doubt 6, 3. Let me just see what the concept was. Just go back to 6, 3. Let's see. Find the midpoint of a line segment, average the coordinates of the endpoints. Huh. Hey, that's what I did the last time. Okay. So to go from 4, 6 to 8, 0. 4, 6 to 8, 0. It's going to be 4 plus 8 over 2, and then 6 plus 0 over 2. So that's going to be 6, comma 3. Yep, there it is. Okay, that was number 6, or number 7. I'm learning as I go. What do you know? I forget some of these concepts, I'll be honest. So lines L and P are parallel. Okay, L and P are parallel. Select all true statements. Triangle ADB congruent to CEF. Okay. Triangle ADB CEF, huh? Nah, not the same shape. Not even the same size. It's a weird one. Slope of line L equal to slope of line P. Yes, because they're parallel. Triangle ADB. So, is this a typo? ADB similar to CEF? No, no way. Nope. Sin A equals sin C. Gosh, this must be a typo. Sin A would be opposite over hypo. Sin C, it does no. This is a obvious mess up. Unit 6, lesson 10. Let's see if they made a mistake. Whoa. Let me see. I'll bet you that is a typo. I should email an illustrative. I'll bet you I can find this problem. What do you want to bet? Huh. I think they meant A, B, C, and D, E, F. But anyways, cosine B, no, that's not going to work. Yeah, so the only one is B. I wrote a proof that triangle AED is congruent to triangle CEB. Is this all the way back from lesson? Oh, unit 2? Okay. Maya's proof is incomplete. How can Maya fix her proof? Okay, so we know AE is congruent to CE. Looks like that's given. And angle A is congruent to angle C. Okay. By the angle, side angle. Oh, she forgot to use vertical angles. So she needed to say angle CEB congruent to angle AED. I want to make sure I got that order right. And the reason being is vertical angles are congruent. Alrighty, that is lesson 1, practice problems.